Today we're going to look at something called symmetry. Symmetry is related to transformation in that our specific kinds of symmetry we're going to learn about have to do with the transformations that we've learned about. But we haven't defined symmetry at all, so I just want to see what you think about symmetry with these four pictures and just kind of decide for yourself which of these pictures you believe has some kind of symmetry to it. And take just a couple minutes to look at those pictures. Alright, they actually all have some kind of symmetry. So what we're going to do now is move through what are our different types of symmetry and then see how those apply to these pictures. Our first kind of symmetry is a reflectional symmetry, and this is related to the idea of reflection that we learned about when we talked about transformation. So reflectional symmetry works as a fold over a line or a flip over a line. So what we need for it is a line. There's two different ways that we're going to talk about how we could draw the line, and that's horizontally or vertically. You could, I suppose, also have kind of like a diagonal line symmetry, but we're not going to be concerned with that. We're just going to worry about a horizontal or a vertical symmetry. So for a horizontal, we would be drawing a straight across horizontal line, and if I would fold or flip over that line, the two pieces should be the same. So for a horizontal, we'd be looking for the top to exactly match the bottom. For a vertical line symmetry, we'd want to draw a vertical line right down the middle of the figure, and the left and the right should then be matching pieces. So where it says examples, we want to go back and look at these pictures and see which ones of these pictures meet those criteria. So first, we'll do the horizontal. Which one or ones of these have horizontal line symmetry?
First two.
First
one.
one has a horizontal line I can draw through there. By the way, what is that symbol?
That's the CBS.
The CBS logo.
PBS.
What CBS? Once we find out about these different kinds of symmetry, if you start looking for them in logos, you will find them a lot. There is something about symmetry that the human eye, brain, whatever controls what we enjoy, loves. There's just something about symmetry that is appealing to us, and designers know this. And so companies want their logo to be appealing to people. And so once you learn about these different kinds of symmetry, you're probably going to start to notice them in a lot of places. But that CBS eye definitely has a horizontal symmetry that if I draw a horizontal line down it, the top exactly matches the bottom. Do any of the other ones have a horizontal line symmetry? Okay, none of the other ones can I fold in half with a horizontal line and make it work. What about a vertical line symmetry? The word mirror has a vertical line symmetry to it. The CBS symbol also has a vertical line symmetry to it. They did a really good job designing that one. They put all kinds of symmetry into there. Okay. So then the third one there says both. So the CBS logo has both horizontal and vertical line symmetry to it. And we will talk about in a couple minutes something special that creates when that happens. Okay. The other kind of symmetry that we're going to talk about today is rotational symmetry. Rotational symmetry, we talked about what a rotation is, and we said for a rotation we need a point and we do kind of a turn or a twist. So we're going to turn around a point. For this, what we need is an angle. How far are we going to turn it? Our point of rotation is always going to be exactly in the center of the object. Okay? So we're not going to select where the point goes. The point is always going to go exactly in the center of the object. And then we just need an angle for how far are we going to turn it and have it match back up with where it is. There's two main kinds of rotational symmetry we're going to be concerned with here. A general symmetry is a symmetry for any angle. We could turn it any number of degrees, some number of degrees, and it's going to work. A point is specifically a 180-degree rotation. What about 360-degree symmetry? What would happen if I took something and I turned it 360 degrees around?
You want to be flipping?
It ends up right back where it was. So this is everything. You can take anything and turn it around, and it's going to be right back where it was. So we don't really consider this as a form of symmetry because then everything is symmetrical, and that's not special. So we're not going to be talking about 360-degree rotation. But general rotation is I turn some amount of degrees, and it lands back where it started, or looks like how it started. And a point symmetry is if I turn specifically 180 degrees. So when we look at our original examples, which one of these, we'll start with point symmetry, which one of these has 180-degree rotational symmetry? That if I put a point right in the middle of it and I turn it around halfway, it's going to look exactly the same.
The word symmetry.
The word symmetry. So I put a point right in the middle of that thing and I turn it around halfway, it's going to still say the word symmetry. And you can test that by just turning your paper upside down. And if you turn your paper upside down and it looks the same, then it must be a 180-degree turn. We'll rotate it.
Wouldn't the CBS symbol be
The
the same?
CBS symbol also has 180-degree point symmetry. And this is the other thing I wanted to say about that CBS logo. So we said that it has both horizontal and vertical symmetry. If you have a figure that has both horizontal and vertical symmetry, it also must have 180-degree point rotational symmetry. Right? It must. So if you have both types of fold symmetry, you have to have this 180 turn symmetry. It doesn't work the other way because this word symmetry has 180-degree turn symmetry, but it doesn't have any fold symmetry. Okay, so it doesn't go both ways, but if you know for sure you have both folds, then you also have the turn. Okay? Which one of these has a rotational symmetry by some amount other than 180 degrees?
The recycling.
The recycling. If we put a point right in the middle of here, I could turn it around some amount, and it's going to look like itself. How far would I have to turn it to make it line back up?
33.
No.
45.
Make it line up exactly how it is.
120.
360.
There we go.
120 degrees. This has 3 points of symmetry around it. Each of those arrows would be a place where it could line back up with itself again. And how big is the circle? 360. So I need to turn it 1/3 of the way around. 1/3 of 360 is 120 degrees. So if I take this and I turn it 120 degrees, it's going to line up. If I turn another 120 degrees, it'll line up again. If I turn another 120 degrees, it's exactly back where it started. So like if we colored the 3 different arrows, 3 different colors, then we could see how those will happen there. After 3 turns, it'll be right back where it started. But we'd want to turn it 120 degrees for each turn. Okay? Questions? Your assignment is at the end of the packet. And one or more of the questions talks about like writing letters and writing words. I'm specifically thinking about like printed capitals, printed capital letters and the symmetry that we can find in those. But on some of them, when it asks you to like design a word or a symbol that has symmetry, if you want to try to do like a fancy font kind of thing, like the word mirror did here, the word symmetry did here, and kind of make it work, that's totally fine. But when it's asking for just like letters that have symmetry in them, I'm thinking specifically of just kind of our block alphabet capital letters.